Okay. The last quiz, as Hannah said, which starts with question 28. Because the way I make the test, I forgot to change that back to 1. Which planets have the longest years? Farthest from the sun. The planets with the farthest from the sun. There we go.
Ooh, I like your color of choice.
Oh, okay.
That is pretty. Why didn't you?
Then I'll change back to it.
No. Okay,
What?
I thought you were switching it. I'm like,
I was, but if you like it, I'm happy. So the actual equation is the period squared is proportional for the right units. You can make it equal to the average radius cubed.
why is period used as a T?
Time.
And Mercury's like minus.
Okay, number 2. What are the 4 inner planets in order from closest to the sun outward?
Mercury, Venus, Earth, Mars. Yeah.
Mercury, Venus, Earth, Mars. To make life easy, we had Jupiter is not an inner planet. Saturn is not an inner planet. So the only 2 that could have been were B and D. They're the only ones that were the inner planets. 3. Which terrestrial planet has the thickest atmosphere? Which one do you immediately cross out?
Mercury. Saturn.
Okay, Saturn was the one I was looking for, but Mercury's a good one to cross out as well. The reason you cross out Saturn is because Saturn is not a terrestrial planet.
What's the answer?
So the correct answer is Venus.
I literally had that.
Oh man. Okay. Wait, you didn't get that one? No, I didn't
Okay.
see the terrestrial.
Amber, is that your question?
I think that one was hard.
I can tell you which one is
I just thought
Bryson.
I said it's probably the freaking last one.
Okay.
That's like Bryson.
The last one. On which planet are virtually all surface features given female names? And Venus was her name. She's got it.
Tell me how
Hey,
I
she's got it.
I failed this quiz. I got a 0 out of 20.
I'm sorry to hear that. Venus. Okay, continuing on where we left off, we finished with the inner planets and we start on the outer planets. Hannah, question? When's the review gonna be?
For the final.
I can have it. Well, my review slides that I'm going to give the lecture on, I can have them up by tomorrow or tonight.
But like the actual like review sheet
Um,
that has a bunch of.
What is today?
I'll have to think about that. I mean, there is a little astronomy to review clearly, but then everything else would just be the review sheets we've had before because it's the same material.
So to pass this test, study the old review sheets.
Yeah.
We should study.
How many exams were all of it?
Yeah.
Should we mostly study questions from the past, or are there going to be a lot of new
So
questions?
like should we?
Because we only have 7 students, many of the questions that you had that were from student written questions will appear again.
But not teacher written.
None of them are teacher written.
They're all
The
textbook.
textbook written.
But there's not really a way to know which ones are student written.
Yeah, there are.
Well, yeah, there are. It's separated. You have 2 separate halves of the test.
Oh yeah, how do you know when it's a student?
Let me show you.
The first half is textbook. The second half is
This is
student.
the one that we just took.
Well, it might vary from one to the other, but the introduction, the multiple choice, identify the blah blah, that would tell you which one it is.
So
It's teacher.
basically, you're not going to have a review sheet.
I think so. But
All it would do would be the ones we already have put together.
Questions are formatted.
That doesn't.
So like these are the way that it was formatted.
That wouldn't change anything.
So like six.
Okay, so then what you're saying is if we study our past tests, we should pass this test.
It is a good way to prepare. Yes. I mean, nothing can guarantee success, but it's a good way because you know that you're going to be tested over the same general ideas, and that a lot of the questions that were student written will show up again.
So are we reviewing on Wednesday and Friday?
Yes.
So then, so we do have class on Friday, and we're not learning new material.
No. Today's the last new material.
So today's the last PTQ.
Yes.
Oh, true. Yeah.
Last.
Perfect. So the outer planets, just a reminder, the outer or Jovian planets are Jupiter, Saturn, Uranus, Neptune. And we've already talked a little about Jupiter, its size, and its it is by far the largest of the planets. Largely hydrogen. It has liquid metallic hydrogen that swirls and makes a magnetic field, just like the Earth has a magnetic field. But its magnetic field is much, much stronger. We talked about the belt zone patterns, and we looked at these here. What were those things?
What are the rings?
The things that I circled.
Oh, you said,
Yeah.
Oh, no, you called them something else.
Well, then the
No, they're moons. There's
You called them something else.
their names are Io and Europa,
Oh,
and
you said the
Callisto and
great
Ganymede.
red spot. Is that what you're talking about?
Okay, so here are the 4 Galilean moons, the moons that Galileo discovered by studying Jupiter with his telescope. And if you look at them, you see that they're very different. Io looks like a hellish planet. And it really, well, it's not a planet, it's a moon. But it really is. Io, because of the tidal forces, remember we talked about what causes high tides on Earth. It was the difference in gravitational force from one side to the other, causing a distortion of the water on Earth. Jupiter being so massive and Io being so close, the tidal forces are so large that Io is constantly being flexed. So it's being elongated. And so that flexing, also Europa passing by contributes to that, causes it to be like wire that you bend. It gets hot. And so it has volcanoes, and those volcanoes are spewing like sulfur stuff. So it really is like the traditional picture of hell with brimstone and fire. Then you have Europa. What does the surface of Europa look like? Okay, kind of like a marble. It's all of these have ice surfaces, Europa, Ganymede, and Callisto. Why? Well, they're far from the sun, right? Jupiter is quite far from the sun. And so being quite far from the sun, they're not getting much radiation from the sun. Being farther away from Jupiter, they're not getting nearly as much flexing from tidal forces. And so they're cold. And so all of them have an ice covering. The ice coverings differ. This one here, the ice is very hard. And I just assert that. How in the world would you know the ice is very hard? You would look and see on Earth they're having a hard crust. And so you have the same types of features like plates that move against each other, and when they collide, you'll have mountains built and you'll have canyons. So they have features there in the ice that are similar to what we see on Earth. Ganymede, this here is a nice big, what we call a sea. It's actually not liquid water, it's ice, but it's ice that's fairly smooth, probably because something impacted there, broke all the ice, and then it froze water over the top of it. Then you have other impact craters. You can definitely see signs of impact here. Europa is more like something that we would have in the Arctic, where you have a lot of melting and fracturing, so it's a much younger surface on Europa. So these are the 4 Galilean moons, and we study those to understand better Earth, and we study Earth to understand better those places.
Can you go back to the slide that was before the moon?
This one?
Yes.
Don't turn it yet. I need a picture.
This is already on Moodle. Okay, so looking at the interior, Europa is considered really important by exobiologists because they think Europa is a prime location to find life. As we look at Europa, we believe it has a crust of water that's frozen, and then underneath has liquid water, and then it should have thermal vents like we have at our ocean floors. Those thermal vents would provide energy and you have the water. They think that it might have all of the things necessary for life to exist. And so NASA has been very careful to not disturb Europa. They don't want to have any spacecraft or anything crash into Europa because they hope someday to send a probe there and look for any life there. And if something else had disturbed it, they could have brought life from somewhere else.
So why haven't they started trying to? Because they don't have the money, or?
There's some good reasons. Number one is Jupiter's way out there. It's much harder to send a probe to Jupiter than it is to Mars. And we had a lot of failures with Mars until the last 2 decades. And in fact, Spirit and Opportunity, they thought that they had lost one of them like within a week of when they landed. So now we have a lot more success, and I'm sure that they're thinking forward to that point, but they want to make sure that there is no chance of failure, because if they land something and it fails, then they've contaminated it. Anything future could be something that came with the first one.
Wait, but how can there be like life that's not in the Goldilocks zone?
Because it is a special environment. This is sea life, not life on a surface.
Yeah.
It does have a rock at the center. And so this here, if you look, this ocean is just a thin part. Then it has a mantle and a core, much like we have. Going to Saturn, Saturn is known for its rings. What do you suppose those rings are made of? It's actually ice. It has ice rings. And those ice rings are thick enough that we see them a lot. But here's something that you never hear about. All of the Jovian planets have rings. There are rings around Jupiter, rings around Saturn, rings around Neptune, and rings around Uranus, which is another reason why I pronounce it that way. They all have rings, but you don't see any of those rings except for the ones around Saturn. The reason you don't see them is because they're significantly different. The other moons, planets, I was right the first time. The other planets, their rings are like ground up rock. They're dark, small particles that you really can only see if you have light shining through them and it's getting blocked by them. And so we call that an occultation. You can only see them in occultation. Saturn is the most oblate of the planets. That is, it's got the biggest equator compared to its height. Why? Well, because it's got those rings and it's spinning. These are spinning pretty quickly. The surface on Saturn and Jupiter both, I think it's about 10 to 11 days for them to do one rotation. They're much bigger than us, and it's a smaller day. It tells you they're really spinning quickly. Let's just move on. Saturn's largest moon is Titan. It has been visited. I'm just going to move on. It has a big moon, has a bunch of small ones. Jupiter has those 4 big moons, a bunch of small ones. Uranus, remember, it's very unique in that it's tilted on its side. It's tilted 98 degrees. So sometimes the sun will be about here. Actually, now that I look at this picture, it's made for the sun to be here, and the pole is going like this. And so sometimes the pole is pointing very nearly at the sun, which means it's getting maximal sunlight. Now, do keep in mind it's much farther from the sun than we are, so it's not going to be receiving as much sunlight as we do. But it is going to receive more. It has a methane atmosphere. We talked about why the color difference in Uranus and Neptune, and it's the amount of methane they think. They're not 100% sure. It's a very cold place. It's a very odd magnetic field, but we have to move on. Neptune, the last of the planets, it also has rings. This picture, I am pretty sure these are drawn on. I'm pretty sure that's not actual photograph of it because, once again, you can really only see it from backlight. It's very similar to Uranus. It has a large moon. The large moon of Neptune is Triton. So think about Neptune, sea god, with his Triton. That's the name of its large moon. whereas Saturn has its large moon Titan. I get those confused because they sound similar, so that's why I have to remember Neptune with the Triton. I know we're going quickly, but we have to because we have to get to Amber so she can get her extra credit. Pluto, in 2006, it lost status. It had been a planet, and then it lost its status. They made a new category they called dwarf planet to cover what Pluto is. Pluto is a large object, but it's nothing like the other planets. The term planet is actually a Greek word that means wanderer. The planets were things that they looked in the sky and they moved with respect to the other stars, or moved with respect to the celestial sphere that Amber's going to tell you about. Pluto does that, but you can't see it with the naked eye. Of course, you can't really see Neptune and Uranus with the naked eye either. But it is unlike the other planets in that it's smaller than the others. It's not a big rock. It's maybe half ice, half rock. And so it is classified as a dwarf planet and a Kuiper Belt object. The Kuiper Belt is a region containing lots of things like Neptune. Included in the Kuiper Belt are things like Eris. Eris is always the one I point to, my go-to dwarf planet. Eris is larger than Pluto. Did you know that there is a thing like Pluto that's bigger than Pluto? Most people don't. Pluto's not unique or special. There's lots of things like Makemake, Haum, I can't remember all the names, Quawar. These things are similar to Pluto. They're orbiting way out there, so they're very hard for us to locate. An astronomer named Mark Brown has found almost all of these things.
Does Pluto even orbit our sun?
Yes, Pluto orbits our sun. Everything in the solar system, by definition, is orbiting the sun.
So it is part of the solar system.
Yes. So the Kuiper Belt is part of the solar system. So is the Oort cloud we haven't talked about. The moon is about a quarter of the diameter of the Earth. You think about that, that's pretty large. It's, bigger than Pluto, if I remember right. But the moon has no atmosphere. It doesn't have enough mass to hold on to gas. 12 people have stood on the moon. That's pretty amazing to me. I like to point out things in this picture. Conspiracy theorists will say that this is made up. And they'll point to things like, where's the shadow of the flag? You have the shadow of the lunar module is going that direction. The shadow of the man is going that direction. Those aren't parallel, and they'll say that means that the light is really close. And, I don't really see a shadow for that flag. Where would it be? Yeah. Some have suggested that this is the shadow, but that's a shadow from something else. I believe it's because it's just such a thin rod that you're not seeing it. But, other things. Why is the flag waving? Have you heard people say that? Yeah. There is a rod right there that you can actually see in the picture. I'm going to erase this so you know where to look. But there's a rod there holding it out, and it was folded. And when you unfold it, it has creases. And so you have a crease there, a crease here, and obviously a crease in between here, and it looks like a crease here. And so it's the creases that make it look like it's waving. Now, if you watch video, there is some motion to it. And then people are, it must have had air blowing on it. The scientific explanation is because this post here vibrated and there was nothing to stop it because there's no atmosphere. So it vibrated very small vibrations. And that's what people were seeing. I firmly believe that this is a legit picture. The astronauts were on the moon. So where did the moon come from? I talked about this before and said we would answer it. Our understanding of where the moon came from is from a collision, something very large. If you look at this picture, that's something that's actually a little bit larger than the moon, is believed to have collided with the Earth in its early days. Or not collided with the moon, collided with the Earth. Collided with the Earth in its early days when Earth was young And the collision, I mean, if you have something that big hit the Earth, it's obviously going to cause a lot of damage. And so our belief is that a whole bunch of stuff from the surface of the Earth, and then the mantle underneath the Earth, got blown out into space. And so we had the Earth, which is now red hot because of this collision, with a bunch of debris that was blown off of it. So this is, after the collision, here's what's left of the Earth with this debris that was blown off of the Earth by the collision. But gravity being what it is, it makes that debris start orbiting in a circle and start clumping. And so the moon is the clump that formed from that debris. Now that's a pretty complicated hypothesis. How would a scientist come up with that hypothesis? There's got to be some evidence, right? Right?
Yes, because
Yes.
when you make the scientific method, it has to have that.
That's what I was hoping, because it's not scientific otherwise. So this is actually, the idea comes in large part because the density of the moon is lower than the density of the Earth. The density of the moon and the composition of the moon, we believe, is much more like the density and composition of the mantle of the Earth. And so the conclusion is, yes, it must be mantle material that got blown up there. The next to last thing being constellations in amber, is going to be talking about the phases of the moon. The phases of the moon, something that we can observe very easily, are described by the sun shining on the moon and us observing. Depending on where the moon is and where the sun is, we're going to see a different portion of the moon. So you might remember when I had students out here going around circles to talk about, I see this part. So that's what causes them. So if the moon is between the sun and the Earth, then we see the dark side of the moon. We call that a new moon. We see, I said the dark side. Remember our discussion about that? Why is it not generally an eclipse in this situation?
It's not an eclipse isn't it because the Earth is in between them?
It's not an eclipse because the moon is either below or above the plane of the Earth's sun, usually. There's a 5-degree tilt between the orbit of the Earth around the sun and the orbit of the moon around the Earth. So most of the time, the moon is not actually between. It's a little above or below. Over here, you can see the only amount of the moon that you see lit up is this portion here. I have black. It does not work there. You see this portion here lit up. That's going to correspond. It's nice how these line up. To crescent, because most of what you see is dark. Here you see half of it lit up. So that's a half moon, and so on. So here are the full moon. You have the sun. The light hits the Earth. The light that doesn't hit the Earth goes on and hits the moon on the other side. Once again, not a, in this case, lunar eclipse, because the moon is usually above or below the plane of the Earth. So we go, the lunar cycle starts with new moon, and new moon means it's dark. And then we go through a waxing. Waxing means growing. Crescent, the shape is a disc. First quarter, waxing. Gibbous. Gibbous means pregnant or humpbacked.
Wait, why does gibbous mean pregnant?
It's in a different language. I can't tell you. Then we go to full, and then we have waning through the same cycles. So that's our lunar cycles, and it's completely dictated just by the moon going around the Earth. Unless you're a flat earther, and then you have to have some other cockamamie, senseless description. Going right to, we've already talked about eclipses, so I'm not sticking with those at all. Asteroids or rocky bodies. Most asteroids fall between the Earth, or not the Earth, between Mars and Jupiter. Not all of them, but most of them. And so we have what we call the asteroid belt. That's the belt between Mars and Jupiter with lots of asteroids. As I said earlier in class, it's mostly empty space. These asteroids are rocks, probably something that was early forming protoplanet that got destroyed, got broken apart. Comets are things like Pluto. Pluto would be a really big comet, but it's the same type of objects that comets are made out of. They're out there in two places, the Kuiper Belt and the Oort cloud.
What exactly is the Kuiper Belt again?
The Kuiper Belt is, I don't have a picture. Okay, so we have the sun here, we have the planets orbiting the sun, and then we have the Kuiper Belt that is a donut-shaped belt going around the solar system in the same plane as the planets, and it has little icy objects like Pluto.
It's a donut-shaped plane? Is that what you said?
Donut shape in the plane of the planets orbiting. And then beyond that, you have the Oort cloud, which is a spherical shell that has the same type of objects but farther out. All right, comets. Comets are those icy things that come falling in toward the Earth. Cool thing about comets is their tails, right? Their tails are huge. And the tails, because they're caused by sunlight causing material to sublime, those tails point away from the sun. So they're not telling you where it's been. They're just telling you which direction's away from the sun, which is surprising to most people. You tend to think that the tail is hanging out behind. It's not. The tail is just material that has been evaporated and released. It can be some grains of sand type stuff that was released when the material around it was sublimed or evaporated. Difference in evaporated, sublimed is sublime is going from solid to gas. And that debris from the tail is what makes the clouds of debris that the Earth goes through when it has meteor showers. Finally, viewing the sky. This is a pretty awesome picture.
When did you go to Chile?
I've never been to Chile. This thing here, that's called the Milky Way. You heard of the Milky Way?
The candy?
Not the candy. The Milky Way is a path that looks like a road of milk in the sky. It looks like a cloud. And that's how it got its name. Things like Kuros Galaxia or Via Lactea.
What does it look like?
It looks like a road going through the sky. And it's white. And so its names, I gave you names in Greek and in Latin, both mean a milk road. That's what we call it, the Milky Way. These things over here, these are called the large and small Magellanic clouds. Those are galaxies. The Milky Way, it turns out, is our galaxy. It's our collection of stars. We're within that Milky Way galaxy. But those two, the large and small Magellanic clouds, those are galaxies outside of our own. Now, I was specifically instructed by Amber not to steal her thunder, so we will turn to Amber now for the rest of the class period. For 10 minutes, that's actually all you have. So, why don't you come gather around, because Amber's going to talk about this.
Is that the right position?
Yeah. So, really, come together.
I'm closer.
She's going to show you things on this.
This is the celestial sphere, and it is a model that helps us explain, so we can understand the sky easier. And this is like, so the Earth would be on the inside instead of on the outside, like that we're looking up. So. And then this theory was found by Aristotle, and he emphasizes about spheres, and it helps us with the positions of where the stars are. And there's constellations that are in the sky, and this like red dot stuff. That's the Milky Way.
Wow, I went to the planetarium this weekend.
That's cool.
Have you done that?
I have gone to many planetariums.
You would like it. I mean,
It's
it's not like a big thing, but like you'd like it. I thought about you when I was there.
Amber?
I'm coming. And then, okay, so if you can see,
Pegasus.
okay, so you see this line with like circles and numbers in it. that is the orbit of the sun, or the ecliptic of the sun
Ecliptic.
around the Earth. And so when it's at 90, that is the summer solstice. And then it has two solstices and two equinox.
Mm-hmm.
And the summer solstice is when it's the furthest north, and the winter is
When the sun is furthest north.
And then the winter solstice is when it's furthest west.
South.
South, I mean, not west, south. And then the number two, no. When the equinox, or the sun crosses the equator, that's the first day of spring, so that's the vernal equinox. And then a lot of, like, you can see the zodiacs, like there's Cancer, Leo, Sagittarius. You can see all of those. They're actually wrong. So when they were basing like the zodiacs, they didn't take into account for the leap years. And so, like, when Dr. Webb was telling me, like, when he was born in, like, the Scorpio thing, his moon or sun or whatever wasn't, like, actually in Scorpio. It was, like, just before. It was in
The other
Virgo.
horoscopes are wrong.
Yeah, so they're not really wrong, but then, like, people who believe in the zodiac signs say, well, oh, that's okay, whatever. And the zodiacs are based on the time that, like, the dotted circle line is in each thing. So, like, right here is Pisces, and so, like, the sun crosses Pisces at this time, so, like, you're born in the Pisces month. That's because the sun is in there. Yeah, that's all my notes. Oh, I was supposed to put Big Dipper out. I don't remember where it is, though. Okay, and then here is the Big Dipper, and it's actually backwards, so the, like, tail of the dipper is supposed to be on this side, and it's backwards because we're looking at it like the Earth is inside rather than like outside.
There's what it looks like if you look in the sky.
Okay, that's all I have on my notes.
Okay. Any questions for Amber?
Oh my gosh.
Okay. Well, thank you, Amber.